So we're here to talk about SPEC SFS 2014. There's three of us here today to kind of talk about things. So I'm Spencer Shepler. This is Nick Principe over to the right. So he and I will be doing the presentation today, and then Ken Cantrell is sitting here in the front row. So in a moment, I'll tell you where we can talk later. So the three of us will be going over the SPEC SFS 2014 work. So this is a review essentially of an upcoming benchmark. So the 2014 SFS revision is scheduled for November this year, if everything holds per schedule. So we're essentially kind of giving you a prequel or a preview of what the benchmark will contain and what we're actually doing with it for SFS. So this is a replacement of an older benchmark, the SFS 2008 benchmark, which is a CIFS and NFS benchmark. And we'll go through essentially how this gets put together, what the framework looks like, the motivation for actually doing a new revision of the benchmark, reporting and then the workloads that are included in the whole overall package, and how you can go about obtaining that when it's actually finally released, is what we'll cover today. One of the reasons why Ken is here is to help us with a BOF tonight. So the three of us will be here, actually I think back in the same room, in the Stevens Creek room tonight from 6 to 7 to go through more questions, content. If there's interest, we might be able to do a demo. We'll see how that goes. We've got quite a bit that we'll go over today, so it's going to go pretty quickly, but I'll give you kind of an overview. We'll be happy to answer questions as we go along, but the longer ones, we'll probably take notes as we go through today, and then we can cover those in the BOF tonight. And I believe that I see probably a couple more people that have been involved with the work that are here as well, so we can kind of go through that if you're interested in more detail on what's there. So we will have drinks and snacks, so it's important. So SPEC is a company or a corporation, so it's essentially your kind of prototypical industry-driven corporation. It's been around since the very late 1980s, focused primarily at first on the CPU benchmarks, that I think we all are familiar with. They still come out today. But there's been a lot of other benchmark types that have been developed over the years through SPEC. The second major benchmark type was actually the SPEC SFS benchmark. And embarrassed to say that I was involved with the first version that was released in 1993. So I got involved in 92 with the first benchmark. And that was built with the purpose of measuring NFS servers, NFS v2, and at that point in the industry was driven by essentially a user-level benchmark called NHFS Stone, if anybody's familiar with it. And so this actually, the SFS benchmark and the SPEC as a corporation was the first time that essentially the industry got together and defined a common benchmark that everybody essentially had input into, understood what the run and reporting rules were, and actually used it then to report results for their products. And it's been very successful, obviously, since it's been around for over 20 years, but it keeps being revised to include material and changes, and this is the first major change to essentially the overall approach and the content that has been made in the last 20 years. So it's pretty exciting work. The disclaimer here is essentially that everything we're going to talk about might change. Okay, so we're very close to actual release time, but we'll probably find a couple of bugs along the way. There may be user feedback. We'll go through essentially kind of what process we're in right now for SPEC, but this is your normal disclosure page. Things might change, so the presentation's probably wrong at this point. So just to give you an idea of the list of companies that are involved, so SPEC is a member or a corporation, so you pay to join SPEC, and then you join the particular subcommittees that you're interested in. So if you're an Intel, you join SPEC and you contribute to the CPU workloads and maybe the graphics benchmarks. If you're somebody like NetApp, then you would join and contribute to the SFS benchmark, et cetera. So SPEC is a company or a corporation that is a really great umbrella for that, and these are the companies that have contributed to the SFS 2014 work. It's been going on for quite a while, so I think that there are probably some that people who have come and gone, and but this captures essentially all of the contributions that have been made. So what are the motivations behind why we go through and do another benchmark release? Obviously, the 2008 benchmark does a perfectly fine job of measuring CIFS and NFS version 3, and it does it in a way that at the point when it was built a very long time ago, it was unique in that it actually generated protocol level operations into user space. And so the fantastic thing about that was You got very reproducible results. You eliminated client variability because there was a lot of change in the client. They weren't written very well. Performance wasn't very good at the client side, and what we really were interested in was actually measuring the server's capabilities and able to get that down to the point where we could get reproducible results, we could report them effectively, and then users could understand essentially what they were getting out of that. And it was extremely successful. Two of the things that I usually think about in the 2008 benchmark was that it found a ton of bugs in the NFS server because you could actually run workloads at stress for a very long time. You could actually generate workload points not at full capacity, but actually at any load point that you wanted within the benchmark. So it was also a very fantastic capability. And then obviously the major point that SPEC was interested in was actually having a benchmark that companies could actually, that could reproduce results and report them effectively then for their customers' consumption. So it's been very successful from that point of view. But over the years then, essentially that grew long in the tooth because of two major reasons. One is that the workloads that you could actually encompass in that benchmark had to be fully coded within the framework itself. So it's like if I wanted to simulate, say, a database, I'd have to actually go and effectively build that behavior into the benchmark code itself. And so it was extremely difficult to do that. The other major deficiency is that we couldn't keep up with all the protocol changes that were happening on both sides of the fence, both NFS and in the SMB space. The protocols kept changing enough and were becoming much more complex that trying to generate a user-level benchmark that wrote the protocol-level messages was very difficult to do because those protocols, one, became more complex. The second was the client's implementation and use of those workloads or those protocols was also varied client to client. So we weren't really capturing that overall system-level behavior. So the major deficiency then is not only am I not measuring the right protocol, but I'm also not measuring really the end-to-end. And there was a realization actually several years back that this was happening, especially with NFS version 4 and the abilities that it had from a protocol standpoint. And we really needed to do something very different from a benchmark or workload generation standpoint. And that's where this work started. The other thing was, like I mentioned, was the ability to add in different types of workloads was very difficult. And so examples of what's been included today is essentially database software build, video data acquisition, essentially data content streaming or video camera streaming, and then VDI or virtual desktop. So a lot of these things, or at least the VDI space, didn't really exist 4 or 5 years ago, and we don't really know what's going to happen 4 or 5 years in the future. So building a framework and a mechanism for us to actually generate different types of workloads is very effective from a SPEC point of view, and that's what we've done here. So one of the things that we also did with the workloads was try to build off of traces. So essentially run a database, understand kind of what the general workload was, try to replicate that behavior in the benchmark. Same thing for VDI as an example. Run VDI workload benchmarks, generate the I/O workload patterns, and then replicate that so we could actually generate and reproduce that. Now that trace level replays are essentially modeling what the behavior is, so it's not an exact replay, but it gives you the ability to get something that's close and very useful from a benchmark reporting standpoint. The other thing here is it really measures client or application level performance. So with the previous benchmark, we were really focused on what's the server side, the traditional file server capabilities, and here it's really more of a discussion about what the application level, so clear through the client, over the network, different network prototypes or protocols, and then the server side pieces as well. The other thing that this benchmark allows is actually local file system measurement, which is, while most of the member companies are interested in things like file servers and the clients that generate the workload against them, the benchmark does allow for essentially that local file system measurement performance and replication of performance and results. And so that also is something that has been missing in general from the SPEC workloads. And the last piece of it is that it was only really possible to measure, as I've said several times, the file server pieces of what was being sold on the market. I couldn't really go in and say, hey, I've got a better network transport. I can demonstrate to you that if, with a 10 gig interface on my file server and client, I get a bunch of different workload characteristic and capability over, 1 gig interface or multiple 1 gigs, and in the future we'll go to 40 and 100. But with this benchmark, the fantastic thing is that I can take that one single component, like a network interface, change it out, same client, same server, do 2 different benchmark runs, and I can publish and compare those so that I can demonstrate to customers what the value of that type of change. And this goes for any component within the system. So, the last comment is a nod towards some multi-tiered storage solutions. So, as we all know, I've got local tiered. It's like, oh, I've got flash and SSD and hard disk drive. I might have, various tape mechanisms in the background. But the other thing that's come to be is also tiering to the cloud. So the idea that I can do that local content, SSD, hard disk drive, and then I can tier to some other cloud property. In fact, there's been a couple of results that have been received and published recently for the 2008 benchmark that are exactly that configuration. And this is one of the things, again, while we're not going to measure the tiered portion, to the cloud, the run and reporting rules, as we'll discuss later, can account for essentially those types of configurations effectively so that we can essentially be inclusive of the different types of products that exist. So just very quickly, the framework, I'll run through the framework pieces and then Nick will come up and go through the rest of the presentation. But there's two major components to the 2014 framework. The first is the NetMist framework, or the load generator that was contributed to SPEC from iozone.org. So the purpose of this is really to give the very basic infrastructure of like, okay, let's take a workload, load it up, make it reproducible, do rate limit, do the measurement and response time and IOPS, et cetera, and then report that content back. And so this requires essentially a 2014 license. And so one of the things I'll take a brief comment to make is the way SPEC works is that you can join as a member company, and what that gets you is you have a voice in essentially the benchmark development, and you can contribute, get early access to the content, and work with everybody else to build it out. If you just want to be a user of the benchmark and have the ability to use it for internal purposes or report results, what you have to do is obtain essentially just a license for the benchmark itself. So if there's one that you're interested in very specifically, then you can license that benchmark. And what you get out of that is the benchmark code. You actually get the source code for the benchmark. You can go through and analyze what's there. You can run the benchmark, gather results, and report them. And we'll go through what the reporting requirements are. But essentially, you get that entire package. And so that's what's included is the NetMist generator. And then a set of wrappers. Those wrappers essentially take the workloads, what Nick will describe later is the business metrics, and essentially runs the benchmark, collects the results, and then captures those in a way that we can report back essentially for the requirements for the benchmark. So we get multi-client support, which you would hope to get out of a benchmark of this nature, so I can run multiple clients. I can run those against a file server. If I have a distributed file system that lies underneath those clients, so to speak, then we'll run it there. We support a lot of different operating system types. Anything that I think would generally be consumed would be supported by the 2014 benchmark. We're protocol and file system agnostic, as I've described. We've essentially jettisoned the NFS and CIFS specific nature of the benchmark and are now down to just file system APIs that are generated or provided by the OS. So I can run on Windows, various Unix variants, and it's using essentially those file system APIs. So I get that either local or remote or distributed file system measurement out of that capability. And then you get the defined workloads. So you get those pieces as well. So you can define workloads. There's a mechanism if you want to define your own workloads and run those internally. They're not reportable through SPEC rules, but you can generate something that would be useful if you're trying to target a very specific workload, and one of the package workloads don't include something that's very useful for what you want to run. And I believe, just briefly, so the different phases of benchmark execution, so the idea is very similar to kind of the previous talk where we go through a validation phase, so we essentially make sure that all the APIs and everything's working as we expect from a functionality standpoint. Initialization of the file set, so you go through and for the different workloads, you'll have a different file system type. It'll do that initialization, so write that data in that file system structure out. Do a warm-up phase, measurement, and then report the results back to the user. So those are the major steps of the sequencing. So the other big thing around this is that the SPEC benchmark, the way we have reporting rules set up is that it's not a single data point. So you'll collect essentially a series of data points at different loads and then report the aggregate result back to as a benchmark workload, and Nick will cover the details of that. So, speaking of which, I want to go to the page.
right, how's that working? Can you hear me? No feedback? Okay. So I'll talk about how SFS 2014 results are reported and the rules that bound the measurement. First, prior to public disclosure, SPEC SFS 2014 results have to be submitted for review by the SFS subcommittee. Why do we require this? Well, in the review process, they're peer-reviewed for consistency and compliance with our run and reporting rules. We also make sure that the disclosure provided is adequate for reproducibility. So end users could, if they desired to, reproduce the result that you have published. Once we accept the results and go through the review process, we publish them to the SPEC website at a time of your choosing once they're accepted. Technically, results can be released publicly without prior review by the SFS subcommittee, but they must be submitted for review if someone asks you to do so. So effectively, this means all results that are published are just run through the committee first, because then you don't have to deal with any potential issues that might crop up, and you've already released them publicly. So effectively, if you're going to publish, you just submit to the subcommittee first. So what are the run and reporting rules? It's not too long of a document, but they bound the measurement and configuration methodologies that you can use in disclosable and publishable configurations. The primary goal of the rules is simply to support SPEC's philosophy of fair and open benchmarking, and secondarily to ensure that that disclosure you've provided is sufficient for reproducibility of the results, like I've said, and for comparability between different vendors and your own results, actually. The run and reporting rules have actually changed quite a bit from SFS 2008. There's not enough time to go over all of the differences, so I'll hit some of the highlights here. First, there's no more uniform access rule. If you know what that means, you're probably fairly happy right now. If you don't worry about it, because the concept no longer exists. So I won't cover that. The next major change is that warm-up time is now a tunable parameter. It used to be fixed at 5 minutes, and now you can adjust it. For a disclosable run, your warm-up time can be anywhere between 5 minutes and 1 week. And since you need 10 data points for a disclosable and publishable run, that means your benchmark potentially could take 10 weeks, not counting dataset creation time and summarizing the results, just for a single benchmark run. Also, there's no longer a requirement to reinitialize file systems before a publishable run. You still can. If you don't, there's detailed documentation that's required that will document, so you have to document all steps from the last system reinitialization. Also, we mentioned there are now 4 workloads that we're coming out with. You report only a single workload at a time. Technically, you could run all of them at once, but you would have to report each workload individually and describe exactly what you did. As a vendor, though, you have a choice of what workloads to publish. You could only publish database results. People might ask you why you're only publishing database results, though, so we expect people to be encouraged to publish all the different workloads. So not requiring a new file system at the beginning of a run is sort of a big change. Why did we do that? There are solutions now where it doesn't make sense or it might not be possible to reinitialize your file systems. A good example of this would be if you're tiering back to cloud storage. You can't go to Amazon and say, I need you to erase that file system. They'll probably give you I'm sure there'll be a lot of amusement at Amazon if you ask for that in a support ticket. Someone, if you want to do that, please do and let me know what happens. I'd love to know. Also, you can have multiple file systems in your hierarchy. So if you're testing on a local like D drive in your VM rather, that's a VMDK that's on a VMFS file system. And so there's NTFS on your D drive that's on VMFS. Then that may be attached over NFS, a network file system, to your file server, which let's say it's running ext4. So if I told you, you need to reinitialize the file system, number one, which one? And number two, really? I have to reinitialize all of those? That means your test setup time is crazy. So now you don't have to do that, but you do have to document all of the procedures and steps that you've taken since the last time you reinitialized your system, your whole solution under test. All the steps and actions that you take have to be generally available. They have to be recommended for customers. There are no benchmark specials, that is against the rules. Having this documentation lets us verify that all of the steps that you've taken are recommended, and they're publicly disclosed so customers could do the same thing. So the big advantage here is that now you can simulate aged systems. Especially when you combine this with a long warm-up time, you can get a much more realistic picture of what a system might look like long after it's forklifted into your data center. And you can show your customers that now in a competitive arena. So how do we define a workload in SPEC SFS 2014? As Spencer alluded to, it's more complex now. I'm saying that they're richly defined, which sounds really cool. What does that mean? We now have separate I/O size distributions for both reads and writes. So for your reads and your writes, each of them separately, there are 16 buckets for I/O size probabilities. Each of those buckets can be a range, and the distance between the two numbers in the range can be 0. So you could say, I just want 8K, so 8192 bytes to 8192 bytes. That's fine, but you have 16 of these buckets, each for read and write. Your minimum I/O size is 1 byte. It's hard to get smaller than that on many operating systems, especially nowadays. And your maximum I/O size, size T, really. It depends on what your platform can do. The maximum I/O size in any of our official workloads that we're going out with is 1 meg. So how do we define the actual workload, the ops that we're doing, not just the I/O sizes? There are 22 file operations that are available. Some of them are data operations, some of them are metadata operations. You have your typical random and sequential reads and writes. You also have whole file reads and writes, which is an interesting concept. I mean, a lot of applications would open a whole file, read it, or write it. You can also do memory mapped I/O. That is not in any of our official workloads, but the capability exists in the framework. There are also some interesting ops, more than just the basic ones. Read, modify, write is the most interesting to me. That's actually measured as an atomic operation. So the whole process of opening that file, reading it, modifying a chunk of it, and writing it is measured as an atomic op. So I think that's pretty unique, because that's a complex operation and a fairly common one. We also have metadata ops. Pretty much all your POSIX file ops that you would expect, make their stats, chmod, access, all those are available to you. We also have some parameters to control write behavior. These should look pretty familiar to you. You control the percent of time a write is followed by a commit. You control the percent of I/O that is done with the ODirect flag. I know that's a flag on open, but it works properly. Also, ODirect is implemented in platform-specific ways. So it will operate correctly on Windows using what a Windows app would do if it wanted direct I/O. And it also on Solaris, Mac OS, the way you turn on direct I/O is slightly different, and that's done correctly in the workload generator. And of course, OSync, the percent of time you will be doing OSync operations. Yes, we have a question. Yes. Yeah, so the question is, since we're no longer issuing protocol operations, how do we do a commit? And so it is just a sync, fsync. There are a few other parameters I'd like to talk about. There are more in the whole framework and the benchmark. These are the two that you want to know about, unless you're doing more advanced custom workloads. Percent geometric is basically file selection skew. This controls how often certain files will be selected for use. So, for example, if you had this set to 100% geometric, your file selection algorithm will follow a geometric distribution 100% of the time. So, a few of your files will be accessed most of the time, and most of your files will be accessed very little of the time. So you can control the percent of IOs that will follow that file access pattern, or that file selection pattern, rather. You can also control the compressibility of your data set. That's pretty basic. That is set to various values in our defined workloads. The data set produced by SFS 2014 is not designed to be dedupable. You would have to have a very small block size. I think it's sub 1K. I'm not sure. But it had to be very small to dedupe the workload at all. So it's designed not to be dedupable. Yes? So is it possible, the question is it possible to specify the queue depth or the number of threads? And so the number of threads is defined in business metrics, so I'll talk about those soon. And then queue depth is something you can tune on your OS or your file server or your NICs, whatever. That's a tunable parameter that you'd have to disclose, but it's up to you. The benchmark doesn't control that. So let me talk about business metrics. A business metric you can think of as a unit of workload. So the benchmarks that we have, like database, that has a business metric, number of databases, concurrent databases, and that's composed of one or more of the component workloads. So those are the workloads that we're not telling you about, the ones that underlie those workloads. A set of execution parameters and the success criteria that really define that business metric. That's the value in that business metric. Why are we using business metrics? Well, now we're simulating real-world workloads, real scenarios, application scenarios. So we want to talk about that in real-world language. And that helps you if you're driving requirements. You're not just saying, I want 150,000 IOPS. You're saying, I want to run 150 simultaneous databases now. So it's a different language. That implies a level of IOPS. I'll tell you a little bit more about that. And these success criteria attach more meaning to the results than just the load level. They attach a certain amount of quality to the ops per second and latency that's reported. And I'll get into more detail on that. So the definition of a single business metric is fixed. They're discrete. I said they were units of workload. You can think of them as discrete units of workload. As you scale up the workload, you request more business metrics. And as you do that, these discrete units of workload are added. So for example, one VDI desktop, that's one business metric. It has 2 threads, we call them procs, 2 threads, each doing 100 IOPS. So when you ask for one business metric, that's what runs, this one desktop. When you ask for 2 desktops, this one still runs, and it has its data set, and it does its thing, but now you're doing another one on top of that. But it has its own data set, its own threads. So the amount of work that each thread tries to do stays constant. You're just adding more threads by adding more business metrics. Question? There can be. I'll get into that. The question was, using this model, there's no contention, and actually there can be. So we'll get into that in the workloads. So what are these success criteria that I talked about? There are more available in the framework than we use in the official workload, so I'm just going to talk about the ones we use. First of all, it's one you would expect, the global operate threshold. The amount of IOPS that you are measuring must be within a certain percentage of the defined ops for that number of business metrics. So if you have one VDI desktop, you're trying to do 200 ops. You have to be within 95% of that, or that data point gets marked invalid. Now we've added a per proc operate threshold. So that looks at the operate achieved by all of your threads, all the procs, and any single proc that falls below its defined operate will cause that whole load point to be marked invalid. So that detects thread starvation. If one of your threads is not getting any work done for the whole benchmark, or very little work done, that will now be detected, and it will cause the whole result to be marked invalid. The last threshold, which is a hard one to talk about, is the workload variance threshold. If you have multiple component workloads, for example, our database workload has both a table workload and a log workload. there's a defined ratio between the operates that those component workloads will try to do. So this threshold says you must be within us, or you can't be more than X% off from that defined ratio with your achieved operates for each of the component workloads. So this means that if your log thread is doing its merrily writing its way along, but your table workload is getting stalled out and not making progress, it's not achieving the operate it needs to, that's not a valid scenario. Your database would stop at that point, because if your tables were bogging down, you wouldn't have the log activity there. So it's not a valid thing that you're measuring. So that would be detected. So this could be typically read or write starvation in a real environment. That will be detected now and mark that load point as invalid. So by attaching the success criteria to the business metrics demand a certain quality of service. They aren't just asking for this amount of IOPS. They say, well, you have to do it within these thresholds. And like I said, if any success criteria is not met, that whole load point is marked invalid. That doesn't stop your test run. It does make it non-disclosable and non-reportable. Typically, your first run, you'll find where you start getting invalid results, and then you will set your load point lower than that. And then all your results would be disclosable and reportable. So what are the benchmark results? What do they look like? There are two principal things we report in the results, and that's business metrics and overall response time. You do also have access to achieved operate and total kilobytes per second, and that's also reported on the website in full disclosures. I'll show you an example of that. The SFS sum file that's produced during a benchmark run contains all this info and more. Like you can break down total kilobytes per second into read and write kilobytes per second, for example. Any disclosure of results produced with SPEC SFS 2014 has to include the summary result, which is the little PR string that you normally see. And that is simply your maximum achieved number of business metrics and the overall response time of that benchmark run. The specific format of that is in the run and reporting rules. You've probably seen one before. Well, for SPEC SFS 2008, the format's very similar. And the full disclosure report is published on the SPEC website. The key visual in those reports is business metrics versus response time with the overall response time. So let me show you an example of what that looks like. So you can see in the corner, we have the number of desktops and overall response time. So that's sort of your summary result, 20 desktops at 2.28 milliseconds. And then you can see our chart where we have business metrics versus the response time, and the dashed line is your overall response time. And if you want more info on what overall response time means, I'll talk a little bit about it here, but we can get into the details in the BOF. And you can see that, like I said, the ops per second and megabytes per second are still reported. They're just not in the chart, but they are available. Question? We're still working out, so the question is, when you go on the website, will there be a different result per workload? How will that look? We're still working on the final format, but since each report is just for a single workload, we expect the results will be grouped first by the workload, and then they may be grouped further. So currently for SPEC SFS 2008, we have the NFS workload and the SIFS workload, which are completely different. So you can either look at NFS results or SIFS results. So it should look similar to that. It'll just be broken down by the different workloads. So like a database page, VDI page. Does that make sense? There are. Yeah, that's a great idea. And of course, this is subject to change. We will probably tinker with the format and make it look even better than that. So if you're going to run these results, you or someone you know might come to you and say, look, I took my platform and I ran all the workloads, and look at what I did. This is great. You might be tempted to do this. Please do not do this. This is invalid. It's against the rules to disclose something like this, and it's not helpful for you either. Why is that? Well, So let's look for 5 business metrics. Okay, look, well that VDA workload, wow, that's like 40 milliseconds response time. But if we do software builds, wow, that's like 1 millisecond or less. So that's much better. But what are you comparing? One business metric is not the same between the workloads. There's a different number of threads, there are different I/O sizes being done, and there's a different op mix. So directly comparing these doesn't make sense. If you were to compare different architectures and the same workload, that's what you'd want to see. So please don't do that. Do this. Now you can actually see three of the lines that were just smashed against the x-axis before anyway. So this takes the same architecture, and we just have a different chart for each workload. So I promised I'd tell you about overall response time. Let me do that now. It is calculated differently in SFS 2014 than it was in SFS 2008. The difference is fairly minor. It's still the area under the curve divided by your maximum achieved business metric, but we no longer assume that the origin point is there, so you have zero business metrics at 0 response time. Because first of all, that sounds a little odd, but also it didn't seem fair to assume that your business metrics versus response time curve would be a certain shape, which is what we're doing if we include that. So now we only include actual measured results in that calculation, which seems like the right thing to do, if that's how you say it. So the net result is overall response times are a tiny bit higher in SFS 2014 versus the algorithm used in SFS 2008. So we've been sort of dancing around what the workloads are. We've sort of hinted at the names. Let's actually talk about the workloads now. First, I'm going to talk about video data acquisition. I could not come up with any better way to describe it than it simulates acquisition of data from a temporally volatile source. Which I hate to read my slides, but what does that mean? So physical security, video cameras, recording that data, or big data ingest, like sensor ingest. It's data that if you don't record it, it will no longer exist, and you can't get it again. Maybe for sensor data you could, but. What is it measured in? It's measured in concurrent number of streams. The workload was primarily defined from IBM Redbooks talking about physical security solutions. This workload does have 2 component workloads. The primary workload is the data stream, that ingest stream, which is almost all sequential writes at about 36 megabits per second, intentionally towards the high end of HD video. And VDA2, which simulates companion applications or user access that happens during the data ingest. This workload, the VDA2 workload, that user interaction workload, ensures that the quality of data ingestion is not adversely affected by other activity going on in that data set at the same time. Basically, starvation of your sequential writes will be detected is the primary goal. It's also a more realistic scenario because, I don't know, you'd be pretty hard pressed to have pure sequential writes happening in any environment, I imagine. So the next workload is virtual desktop infrastructure. I had to actually look up what VDI meant because we've been just saying VDI for so long. It simulates the workload generated by a hypervisor to support a heavy steady-state knowledge worker. It's derived, like Spencer said, from traces from Hyper-V, ESXi, and Xen environments. And it's measured in concurrent desktops. This has just one component workload, like I said, with 2 threads per desktop. Sorry?
Why heavy only workload?
I have what?
Why the heavy state knowledge worker?
Oh, yeah, we had to pick one. So why do we only have this one steady state knowledge worker workload? We had to pick one. And it was sort of out of scope to do like a login storm or boot storm. So it's a data heavy workload. As you would expect, a hypervisor doesn't do much metadata. It has 1% access. The rest are just reads and writes. So like I said, it simulates a steady state VDI workload, no boot storm or login storm. This is So the intent really is so you can measure, how many VDI desktops can you support doing steady state. You'd need a separate workload for Login Storm or Boot Storm. Or Virus Scanner Storm. All the writes are direct I/O, which is what you'd expect from a hypervisor. The data set is about 50% compressible, which seemed an accurate average for real data sets. And the files are fairly large. I feel sort of odd saying 500 meg files are large, but it's about 11 gigs, I believe, per desktop, which is fairly accurate today, at least. And the data set is not dedupable because none of these data sets are dedupable. So it simulates a full clone environment, not a linked clone environment. The next workload is a software build workload. You can use this to simulate large software project compilation or the build phase in an EDA workflow. And it's derived from traces from actual software builds, and also that was sort of cross-referenced against some clear case documentation, implementation guides, I think. And it's measured in concurrent builds. Again, this has one component workload, but unlike VDI, it is very metadata heavy. 87% of the workload consists of metadata hops. Now, I mentioned whole file reads and writes. The reads and writes, all of the reads and writes for software build are done on a whole file, and the average file size is actually a Gaussian distribution centered at 16K with about 500,000 files per build. And the files are highly compressible, as you would expect from source code. This workload is interesting because it has the most potential to actually be cached or modified by the load generating clients. And why is that? Well, it doesn't do direct I/O because I don't know of a software build that opens files with ODirect. So that simply means that the OS can and will interject itself into that I/O path and try to help, which may hurt in your case. This is also the most likely to cause a bottleneck on your load generating clients. So that may be what you want. You may want to measure how performant, which I hate to say, how performant your solution is with this number of clients and this file server. So you might want to show that, well, you can only do this number of builds with this number of clients. If you want to show how many builds you can do on the file server, you have to be careful and make sure that you have enough clients to actually support that workload. We have some guidance on this in the user's guide and the run-on reporting rules to try to get you on the right track. Finally, we have the database workload. It doesn't have a cool code name like the others, like software build is called software build. It's just database. It simulates OLTP database consolidation, so taking multiple small databases and transitioning them onto one set of resources. So clients and file server, since this is a whole solution benchmark now. The workload is derived from real database traces from Oracle. And it's measured in concurrent databases. And this does, like I said before, have two component workloads, a table workload and a log workload. This is also an interesting workload because for this workload, all of the database table threads for a business metric share the same data set. So this goes back to contention like you were saying. The same data set will be used by all, I forget how many threads now, but by all of the threads for a database table for a single business metric, they use the same data set. So multiple threads are working on those same files, which is what a database table would do. You'd have multiple threads working the same set of data. This workload also has moving hotspots in the data set. Certain offsets in those files will be accessed more than others, and those hotspots do move over time. We have an example of that we can show you at the BOF tonight. Just a raw chart, raw data. So here again, we have the threshold, the success criteria, to make sure that your log and your table threads are achieving the proper workload ratio between them to make sure that we're simulating an accurate scenario. Okay. So to prove to you that these are realistic and cool workloads that are from real traces and real environments, let me show you the read size distribution. So you can see can I say that? Yes, almost all of the I/O buckets shown here have a probability less than 50%. So there's a wide variety of I/O sizes that are used for everything except for your database table. So you can see software build, the red dots, I/O, it can go as low as 1 byte to 512 bytes, which fairly low probability, with a higher probability centered around between 4 and 8K. Question? That's correct. So there's nothing for VDA1 on this chart because it's ingest only, it does no reads. So let me show you the writes so you can see those. Sort of changes a little. You can see VDA1 and VDA2, the distributions are actually identical. But VDA2 it'll do hardly any writes at all. But it is the same distribution. And you can see the database log has a wide variety of writes. Of course, it's not really going to do any reads. So you see it mostly show up here on the write distribution. I apologize if you're colorblind. Actually, in the backup slides, I have, those with patterns, which are very hard to see on a projector, so I changed it. But if the slides are in front of you, it is legible. So just to wrap up here, the workloads that we have in SPEC SFS 2014, they're richly defined, as I've described. They're realistic. They're based on real solutions and real applications. Results are now measured in business metrics. That's your primary metric, how you specify load and how you report your results. It's real-world language, which can help for requirements, either if you're doing internal development to test your product or requirements for other vendors. Quality of service for your I/O is attached to those business metrics, so you can't have thread starvation. You have to have good quality for all your threads for that load level. Performance is now measured at the application level. The performance of the whole solution is measured because the clients and switches, everything in the solution is now involved in the performance of the solution and is measured. And again, they're modern scenarios. We include the workload definitions and the source code. It's available to all licensees. If you buy the benchmark or you are a SPEC member, you have access to the source code and the definitions. And this is all to support open, transparent, and fair benchmarking. So where might we go in the future? There are many directions we can go now that we've sort of revved the whole benchmark suite and the underlying workload generator. We now have more options available to us. So we have pluggable workloads. You can make your own custom workloads. We can make more workloads and then provide those as official workloads. So we've already done some work with a home folder scenario based on Microsoft's FSDT. The HPC market also makes sense to get into. We may go to support more storage APIs. So for example, raw block support or object storage using some protocol. I've heard about many different ways to do that this week. So. But CDMI or HDFS would certainly be of interest and relevant. SPEC is also working with SNIA. There's a memorandum of understanding there to work on the Emerald standard to provide NAS Energy Star. The intent is to use this workload generator to provide the workload for that Energy Star and Emerald benchmark. So like VD bench for the block workload. And again, we provide the source code for everything. If you want to provide patches and you're a SPEC member, we welcome that. Even if you're not a SPEC member, you can ask us questions about the source code. Actually, well, if you bought the benchmark, you can. If you didn't buy the benchmark and you're looking at the source code, we want to talk to you. But it's provided, so you can see how all the IOs are done, how the IO size is selected. You can review all that and make sure it's beats with what you expect. So thank you for coming. For a lot more detail, please come to the BOF tonight. We'll have at least myself, Ken, and Spencer. That is 6 to 7 in this room.
And then the Emerald BOF is immediately following.
Yeah, and the Emerald, so the NAS Energy Star BOF immediately follows. So it's a pretty good one place for both interesting topics. So please come. Thank you. Do we have any time for questions? No questions.